This is Dr. Shubhajit Roy Choudhury. I am an associate professor at the School of Computing and Electrical Engineering, IIT Mandi. I work in the area of non-invasive diagnostic systems for the point of care testing of patients. Here we are developing the prototype of a non-invasive diagnostic system that can estimate the concentration of albumin in urine. Albumin is a protein present in biofluids that performs a wide range of metabolic functions. Albumin is present in circulatory system and constitutes a major component of the protein present in the biofluids. Albumin plays a vital role in biological systems, including maintenance of acid-base balance, transportation of fatty acids, exogenous and endogenous ligands and metabolites. There are various diseases like diabetes mellitus, microalbuminuria, cirrhosis of liver, hepatitis and various other diseases that can be estimated, that can be predicted from the concentration of albumin in blood and urine. The method is based on the fluorescence in near-infrared region of 700 to 850 nanometer by using a novel dye with the test mixture. The chosen near-infrared range of 700 to 850 nanometer has the advantage of absence of autofluorescence from the biomolecules present in urine other than albumin. The system consists of light source, spectroscopic chamber, sensing and computation unit. The dye that has been used as a fluorescence indicator for the presence of albumin in this study has been tested earlier with bovine serum albumin and human serum albumin with convincing results. The system comprises of light source, reaction site and sensing unit. In order to design a low-cost near-infrared spectroscopy device, commercially available high-power LED light source from Muser India Limited of peak wavelength 740 nanometer has been used. To keep the wavelength and the intensity of the LED constant, a constant current LED driver circuit has been used. The reaction site consists of a cuvette where the dye is mixed with the urine sample. The sensing unit consists of a photodiode and a signal conditioning circuit. Two LEDs placed opposite to each other on the two opposite sides of the cuvette provide the light source, and the photodiode is present perpendicular to the direction of the two LEDs to capture the emitted radiation. The radiation that is emitted is at a wavelength of 806 nanometer, which is because of the fluorescence of the dye plus albumin molecules. Basically, the dye molecules get bound to the albumin molecules and re-emit radiation at 806 nanometer, which is captured by the photodetector. The dye has been prepared using high performance liquid chromatography grade dimethyl sulfoxide. Clinical trials have been carried out on human urine samples collected from the medical unit of IIT Mandi with prior informed consent following the Declaration of Helsinki 1964. Once the urine samples have been collected, the results have been also validated against the standard patholab results. So, we have found a significant agreement between the experimental results and the patholab results. So, this is our urine albumin estimation system. As you can see, it is actually a portable gadget. This is actually a collaborative project between me, Dr. Shubhajit Roy Choudhury, and Professor Subroto Ghosh, who is actually a professor in chemistry in this institute, and Dr. Prosenjit Mondol, who is a biologist in this institute, who is also an associate professor. So, as you can see over here, we have these two LEDs and a photodetector over here. So, the LEDs are sending the radiation, near infrared radiation at 740 nanometer wavelength, and this photodetector is picking up the emitted radiation from the fluorescence due to this dye plus albumin mixture. So, I am putting the cuvette over here. So, this cuvette is having the urine plus dye sample, where the urine is collected an hour before and the dye is mixed with it. So, the incubation period is 1 hour. So, 1 hour, for 1 hour you have to keep this urine plus dye sample as it is. This is actually the incubation period. After the incubation period is over, you put the sample over here, then cover it, and now you get the result in the display. So, it is a very simple mode of operation and can be used by any person in the rural peripheral areas, particularly if it will signal any early problem in the kidney or even diabetes mellitus, cirrhosis of liver. All these things can be predicted if there is any increase in concentration of albumin in urine. In contrast to the urine dipsticks available in the market, which has a sensitivity of 30 micrograms per deciliter, the device has a sensitivity of 3.3 microgram per deciliter. Specifically, diseases like microalbuminuria can be detected only using this device, which cannot be detected using the dipsticks available in the market. Therefore, a lot of patients who have got potential kidney problems can be saved from early kidney failures by doing diagnosis using this device.